exercise 2.3. This is an easy exercise. First question, which of the following relations are functions? We know the definition of a function. Every element of the domain should have a unique image in codomain. Then it becomes a function. Give reasons. If it is a function, determine the domain and the range. The first question, it is given in rooster form: 2, 1, 5, 1, 8, 1, 11, 1, 14, 1 and 17, 1. This is actually a constant function. See, I am showing it by the arrow diagram. The domain is 2, 5, 8, 11, 14 and 17. The range has only one element. So 2 is related to 1, 5 is related to 1, all these elements are related to 1. So it becomes a constant function. Is it a function? That is the question. Yes, every element has only one image. So it is a function. Give reason. So you can write the definition of a function. Every element of the domain has a unique image. Therefore, it is a function. This relation is a function. And we give a special name to this function as constant function. We have already seen. If it is a function, we have to write domain and the range. So domain is set of all first elements: 2, 5, 8, 11, 14 and 17. Range is set of all the second elements. It has only one image, which is 1. Range has only one element. Second subdivision. Let us write the relation which is given in rooster form: 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, Now let us show this by arrow diagram. It's not necessary to draw the arrow diagram. It will be easy for me to explain it. That's why I'm showing it using arrow diagram. Set of all second elements I'm writing. So 2 is related to 1, 4 to 2, 6 to 3, 8 to 4, 10 to 5, 12 to 6 and 14 to 7. It's actually divided by 2. Y is equal to x by 2 is the relation. Is this a function? Yes, distinct elements have distinct images. So every element has a unique image. Let us write that reason. Every element of the domain has a unique image. Therefore, it is a function. Now, in case it is a function, we have to write the domain and the range. Domain is set of all first elements: 2, 4, 6, 8, 10, 12 and 14. Range is set of all second elements: 1, 2, 3, 4, 5, 6 and 7. Third subdivision. The given relation is 1, 3, 1, 5 and 2, 5. Domain has two elements, and here we have two elements. One is related to 3, one is related to 5, and 2 is related to 5. If you see, the element 1 has two images. Therefore, it is not a function. Each element should have a unique image. Here, the element 1 has two images. We'll write that reason. The element 1 has two images, 3 and 5. Therefore, this relation is not a function. Second question. Find the domain and range of the following real functions. Finding the domain and range of the given functions is an important question, very, very important question. Even in competitive exams, they ask these questions. F of x is equal to minus absolute value of x. Let us discuss about the domain. X can take any real value. So domain is R. Range. We know that absolute value of x always is a positive number, but there is a minus sign in front of it which makes the number negative. So the answer is always a negative answer now. So it takes all negative real values. I can write it as minus infinity to 0, because if x is 0, the answer will be 0. So 0 is included. This is the range. When you find the domain, you have to be careful if x comes under the root sign. If x comes under the root sign, whatever is inside the root sign, it has to be a positive number. So this has to be greater than or equal to 0. And if f of x comes in the denominator, say, so if x variable is in the denominator should not become 0. This is the condition. And in case if you have a function under root but it is in the denominator, say, then f of x should be strictly greater than 0. So you have to know these 3 points. I'm repeating them. If f of x comes under root sign, whatever is under root sign, that should be greater than or equal to 0. It cannot be negative. If it is negative, it becomes a complex number. If x term is in the denominator should not become 0 because it is not defined. If you have 1 by root of or any constant by root of f of x, if you have x term in the denominator under root, f of x should be strictly greater than 0 because it cannot be equal to 0 as it comes in the denominator. Now let us do second question, second subdivision. F of x is given as root of 9 minus x square. As I said, the function is under square root, which is in the numerator. Therefore, it should be greater than or equal to 0. Let us solve this inequality. 9 is greater than or equal to x square. That is, x square is less than or equal to 9. I have written the same inequality. I am taking square root. I cannot write plus or minus 3 on the same side. If it is an equation, I could have written plus or minus 3, but it is an inequality here. So I have to write plus root on one side and minus root on the other side. So x can take all real values between minus 3 and 3, including minus 3 and 3. So let us write the domain. So domain for this function is closed interval minus 3 to 3. Now let us think about the range. If x is 0, f of x is equal to positive square root of 9 minus 0, which is plus 3. We don't write plus or minus if square root is there already. F of x will be root of 9 minus 0, which is 3. If x is plus 3 or minus 3, you get the same answer, which is 0. Root 0 is 0. So for negative values also, x square is positive. Therefore, range will be, it takes all real values between 0 and 3, including 0 and 3. This is the range. It is an important question. Question number 3. A function f defined by f of x is equal to 2x minus 5. This is a very simple question. Write down the values of f of 0. Just you have to plug in the value 0 here. 0 minus 5 is minus 5. Then calculate f of 7. 2 sevens are 14, which is 9. The third one, f of minus 3. 2 times minus 3 is minus 6 and minus 5, which is minus 11. Question number 4. The function t, which maps temperature in degrees Celsius into temperature in degree Fahrenheit, is given by t of c is equal to 9c by 5 plus 32. We have to find t of 0. So c value is given as 0. If you put c as 0, you get 0 plus 32, which is 32. Second one, t of 28. c is given as 28. So 9 into 28 divided by 5 plus 32. 9 into 28 is 252 divided by 5 plus 32. And 5 5s are 25, 0 and 4 plus 32. The final answer is 82.4 degree Fahrenheit. The third one, t of minus 10. Substitute c as minus 10. We can cancel. So it is minus 18 plus 32, which is 14 degree Fahrenheit. The last subdivision of the fourth question. The value of c when t of c is 212. So substitute t of c itself as 212. 9c by 5 plus 32, we have to find the value of c. 212 minus 32 is equal to 9c by 5. This difference is 180, and take 9 by 5 to the other side, it becomes 5 by 9 equals c. So c value is 100 degrees Celsius. Question 5. Find the range of each of the following functions. Here domains are given. You have to find only the range. F of x is 2 minus 3x. X belongs to R and x is greater than 0. So all real values which are more than 0. This is the domain given. We have to find the range. It is given that x is greater than 0. Minus 3x. If I multiply both sides by minus 3, so 0 into minus 3 is 0. Since I am multiplying by a negative value, I have to reverse the inequality. Remember, if I divide or multiply by a negative number on both sides of an inequality, I have to reverse the inequality, so it becomes less than. Now let us add 2 on both sides. So 2 minus 3x is less than 0 plus 2, which is 2. This is our f of x. So f of x takes the values which are less than 2. Therefore, the range is minus infinity to 2. 2 is not included, so open interval. So this point you should remember, if you multiply by -3, the inequality should be changed. If you multiply or divide by a negative value, which you are going to learn in inequalities lesson. Second subdivision, f of x is given as x square plus 2 and x is a real number. So domain is given. We have to find the range. We know that x square is always positive and you are adding 2 to it. Right? The minimum value of x square will be 0 and plus 2. As you increase or decrease the value of x, this f of x is going to increase. Therefore, I can say that x square is greater than or equal to 0, we know. Now let us add 2 on both sides. So x square plus 2, 0 plus 2 is 2. This is our f of x. So f of x is always greater than or equal to 2. Therefore, the range becomes 2 is included to infinity. Third subdivision, very simple question. F of x is equal to x. This is an identity function and x is a real number here. So whatever x is, f of x is the same value. If the domain is R, range is also R. Example 17. F of x is equal to root x. It's not a polynomial. G of x is equal to x. Be two functions defined over the set of non-negative real numbers. Let us find f plus g of x, which is f of x plus g of x. Root x plus x. And f minus g of x will be f of x minus g of x, which is root x minus x. F into g of x is equal to f of x into g of x. So root x into x. Root x is power half and that is power 1. Half plus 1 is 1.5, which is 3 by 2. F divided by g of x is f of x divided by g of x. Root x divided by x. We can simplify. It becomes 1 by root x. We have a condition that x should not take the value 0.